Hello, my name is Holly Lewis and I'm going to be doing a walkthrough of Spotplotter and show you how it can be used to quantify spotting assay experiments. For this demo, I'm going to be using this dataset provided by Dr. Mandy Mason. It contains images of microbiome tuberculosis spotting assays, some of which have ATC, a chemical activator of the CRISPR system, and I will use Spotplotter to determine what the effect of this additive is. So to start off, you need to create metadata to show the program what your experiment looks like. And the first step of this is to show it what the individual plates look like. So in this experiment, this is one of the images. You can see here I've got 3 strains, or 3 repeats, or essentially 3 times where the dilution series repeats itself. Each strain has 4 columns, giving me 12 columns in total and 8 rows. So in this case, it is the same as the default variables, but you can change it. For example, if I had 4 strains, I could change that here and you can see it will adjust. I can change the number of rows or the number of columns, and you will do this until it reflects your experiment. I can also change the dilution series, and this will be important later on when it uses it to calculate the relative dilutions at each point. I also have this option of adding a gap between strains, which you will select if there is a blank column in between each strain. The other thing is square grid cells. So square grid cells is not about the total grid, but rather the distance between neighboring spots in the X and Y position. In this case, I do have a square grid. You can see here that this distance here and this distance here is even, but an image like this, you can see that it is much closer this way than downwards. So my settings for this experiment, I don't have a gap between strains, and I do have a square grid. If your spotting assay is done by hand or each row is done separately, it is very unlikely that it would have a square grid, and so it is probably safer to leave it unchecked, but you can experiment for your particular experiment. Next, I'm going to define what each plate looks like. So starting off, I need to have the file name, so I'm just going to copy it from here, including the extension. So in this case, the images are .jpg, and I'm going to add it. You can see that this reflects the plate layout that I did before. Next, I'm going to add the names of each strain. So these are the strains that I will have. I'm just copying and pasting them in. Or you can, of course, type them. And I'm going to assign them to its relative position. So this would be in position A, position B, position C. So I'm happy. This is my plate number 1. I'm going to continue this process for all of the plates. So next I would do this plate. So I'm going to copy the plate name. Don't forget the file extension, add, and I can assign the strains, but in this case it has the same layout as the previous one. So I'm going to click copy previous, which will just assign the strains the same way that it was on the previous plate. I'm going to add my next plate and the file extension, and this is one of the plates with ATC, so I will check additive and I will write ATC. And once again, the strains are in the same position. I will click copy previous layout. So I'm going to repeat this for all of the plates, and once you're finished, you can click next. This will prompt you to save the metadata, and this will allow you to reuse it if you're going to rerun the experiment later. So I'm going to call it metadata demo and save. Next, I am going to upload the assays that match that metadata by clicking upload assays, and then I will select all of the images. One note, you can just select everything you have and it will only upload those that match the metadata file. And then once I have done that, I'm going to click next. Here is the first image. The cropping stage is very important because it is used to scale all of the quantification values to a constant real life distance. So in this case, I'm going to use the width of the plate as my constant distance. So when I crop it, I must make sure that all of them are cropped to the exact same reference point. So here you can see that this width, I'm going to crop it every image the same. Okay, I'm going to click crop, and now I am going to alter the parameters here in order to get the best segmentation. So starting off, I can see it's including a lot of these small dots. If I didn't want to include those, I could increase this slightly. So looking at this, overall, it's very good. It has identified all of the dots, which I can see, but it is not reaching quite to the edges. So to fix that, I will increase the block size. So block size, you can think of growing what is already there, growing or shrinking what is already there, but increasing or decreasing the threshold will add or remove detected regions. So I have altered the parameters, and I can see that most of the spots are nicely detected and detected all the way to the edges. However, there is a lot of area here where there's a light reflection that is being identified as a foreground spot, but I can change that in the next stage. It is more important that the actual spots are accurately detected. It doesn't matter if more background objects are being detected. So using these tools, I can erase or add and fix these mistakes. So starting off, I can toggle this outline on and off to make sure it is a good reflection. The next thing I can do is zoom, and I can use these scroll bars to navigate around the image. I can also undo or redo any changes that I make with the tools. I can use the pen tools to add if it is missing something. For example, if I wanted to add a spot here, and I can undo that with the undo redo. And this is eraser tools. There is a thinner eraser, a thicker eraser, and then a flood eraser, which will remove all connected white regions, like so. So starting off, I can see that this big light reflection here is being detected as a spot. So I'm going to zoom in, and I will first off disconnect it from the neighboring spot. And I will disconnect it from this plate edge. And now that looks like a more accurate reflection. Next, I can see that there is this whole area that's been detected. I am just going to use this flood erase tool, and I'm going to remove it. And I'm going to remove that. So you can see that all of these little bits are still left over. I'm going to zoom out so I can have a better idea of it. And I'm going to take this eraser and I'm going to erase it. So one thing, you can make your changes on either image and it will map. I'm just going to look around. I'm going to remove this big area over here and these small areas over here. Looking here, I can see that these two spots are connected. They shouldn't be. So I'm just going to disconnect them with that thin eraser. So looking at this, I'm pretty happy with the result. Any other changes you see that you could make, for instance, down here. I think it's picking up a bit of a light reflection at the bottom. And once I'm happy, I will click next. So here you can see it has detected the grid and quantified it. So one thing to note, even though things are spilling outside their primary grid block, for instance here, it's all still counted in the main grid block. So this grid doesn't need to be perfect. It more is showing you what the detected grid is. As long as things are mainly within their cell, they will be counted correctly. One thing to note, if anything is dark gray, it means it isn't counted because of the way that it's spread out over too many grid cells. So for example, if I hadn't disconnected these two areas, they would show up as dark gray because a spot couldn't possibly be taking up so much of two different blocks. So if any of your actual spots are dark gray, make sure you go back and erase anything that's connecting it. If the grid is being detected incorrectly, I'm going to click Override Grid, and I'm going to give the algorithm a few more bits of information to help it calculate the grid. So I can add points. So for instance, if you had a very sparse assay, then you could add points. So for instance, I could add here and here, even if there isn't necessarily a spot. And I could add in this column. So to get a good result, start adding in this left side and make sure you add a few columns and a few rows over here. If the grid is incorrectly detecting, for instance, if I added a row of spots up here, it would shift it up. So here you can see it would then ignore all of these. So then you would go to override grid and you would just remove any spots. So here it's refreshed because I made those changes, but sometimes there may be detected areas up here that will mess with the calculation. You can just click remove points and you can click on the center points to remove. Once you're happy with it, you can click next and it will prompt you to the next plate. So remember to crop this plate the same way you cropped the previous one. So here I'm cropping once again to the edge of the agar. And I will redo this process for as many images as I have. So once I've clicked next on the final image, I will be prompted with a save project as, and this will be saving all of the experiment names. You can see over here, this is the default name. It has the date. This is where you'll put your experiment name, the version, and the time. So I'm going to put my experiment name here. It will then download the results. This time may vary based on the quality of your images and the number of images. You can just give it time, and once the finish button pops up, it is ready to be closed. Over there, it's finished. I can click finish and that will close the program. So this is an example of what your output could look like. In this folder, you will see that there are 3 things. Firstly, there's an Excel spreadsheet of all the data. Next, there is a log, and next there is a report. So to open the log, you will get something like this. And this will show you what your assay looked like, what the experiment that, the layout that you set was, any settings that you used, the strains, the columns where those strains were, there was a gap, and the variables that you used. Here will show you the images and any tool usage. So you can see here, I erased that portion over there, and the contour overlays, and it will repeat that for all of the images. The next thing that is there is the report, and this will show you a summarized view of the data. So it will graph it for you based on the strain. So here you can see there was 2 repeats in this case. The blue is a control and the red is an additive. So in this case, it shows that there has been a knockdown and all the statistics. And it will plot an average curve, and it will repeat this for each of the strains. The next thing it will give you is an Excel spreadsheet that will look like this. So it will show you the file name, the additive if there was one, the strain at that point, the quantification that it calculated, the dilution at that point, the normalized quantification value, and the normalization value that it used. You can scroll down, you can see here's the control plates, and here is the next strain, and so on. So that is a run through of how it works. If you have any questions, you're welcome to reach out and email spotplotter@gmail.com. Thank you.